Okay, today we're going to focus on nonlinear inequalities. So let's say you have an inequality like this. It's a polynomial set less than 0. So you're looking for where it's negative, where it falls below the x-axis. So let's graph this. This is a parabola. If you were going to graph this, you would want to factor it, like we factored it here. And then you would set each of your factors equal to 0. And you would find that at x equals 3, and x equals -1, you have x-intercepts. So you would make an x-intercept here and here. We know that our y-intercept is down here at -3. And it's going to look something like this. Okay, so that's what the parabola looks like. When we ask you when is it less than 0, we're asking for this part of the parabola right here. And that falls between the x-intercept -1 and +3. That's the interval. We would use parentheses because we're just using the less than symbol. We didn't use the less than or equal to. So we just use parentheses instead of brackets. All right, so I'm going to show you another way to do it where you're using a number line instead of a graph, because sometimes graphing the polynomial isn't as easy, or it might just kind of be a pain. And so what I want you to think about is how those zeros that we just found, this was a 0 and this was a 0. Those zeros are considered critical numbers. And if you draw it on a number line and you graph those zeros, so at 3 we had a 0 and at -1 we had a 0. And then you think about the parts on either side of those zeros as intervals that you want to check out. Because if you'll notice at those zeros, that's where it changes from positive to negative, and then from negative back to positive. Those zeros are always the place that happens. So that's what you're going to be checking for. All right, I'm going to scroll down just a little bit, and we're going to talk about how to do that. Okay, so sorry it erased, but again, you had those critical numbers here at 3 and -1, and we're checking for these intervals on either side of those x-intercepts or those zeros. So what we're going to use is 3 test intervals, and you just choose values for x and see what the sign of the y value is for those values of x that you're going to choose. I'm going to plug it into this polynomial. All right, so in this interval, on the one over here on the left of that x-intercept, I'm going to choose -2. On this interval here, between the two x-intercepts, I'm going to choose 0. It's just an easier one to use to plug in. And then on the one on the right-hand side of the last x-intercept, I'm going to choose 4. And what you're going to do is plug it in and just kind of see what the value is, if it's positive or negative. I'm going to use the factored form, x minus 3 times x plus 1. So when you plug in -2, you're basically doing -2 minus 3 times a -2 plus 1. And you're going to get a -5 times a -1, which gives you a +5. To be honest, I don't really care if it's what the number value is. All I really care about is the fact that it's positive there. So when I'm doing this in my head, I just figure out that that's negative, and when you multiply 2 negatives together, you get this positive. So let's plug in 0. We're going to do 0 minus 3 times 0 plus 1. That gives me a negative times a positive. A negative times a positive is a negative. Okay, when we plug in 4, we're going to do 4 minus 3 times 4 plus 1. 4 minus 3 is a positive value. 4 plus 1 is a positive. When you do a positive times a positive, you get a positive. So in this interval, on the left-hand side of that -1, it's a positive interval. All of these numbers, it doesn't matter which one you plug in, it's going to give you a positive value. If you remember, our graph looked like this, and everything on this on the left-hand side of that was positive right there. Anything between -1 and 3 was negative. Anything to the right-hand side of 3 was positive. So when it asked me to solve this inequality right here, I can tell by the graph up here that this would be the interval that I'm talking about. So again, my answer would be from -1 to 3. All right, let's do some other examples. Okay, for this next one, we need to factor it. So x minus 3 times x plus 2. We want to see where it's less than 0. So my critical numbers are whatever makes x minus 3 equal to 0, which would be x equals 3, and whatever makes x plus 2 equal to 0, which is x equals -2. So I'm going to draw the number line, and I have a critical number at -2 and one at 3. So I'm going to choose some test points, some x's, and see what the sign of my y is going to be. And I'm on the left hand side of that -2, I'm going to choose a number like -3. For numbers between those two x-intercepts, I'm going to choose 0 again. 0 is just the easier number to choose. And on the right hand side of that 3 for that interval, I'm going to choose 4. And then I'm going to plug them into my factors. So -3 minus 3 times -3 plus 2. That gives me a negative value times a negative value, which when you do a negative times a negative is a positive. When I plug in 0, I get a negative times a positive, which is negative. And then when I plug in 4, I get a positive times a positive, which is going to give me a positive. So it's positive on this interval, negative here, and positive here. And we're looking for where it's less than 0, which again is this little part right here. So it's going to be between -2 and 3. I'm still using parentheses because I just have the less than symbol. I don't have less than or equal to, so we just use parentheses there. All right, I'm going to erase all of that just to give me more room. Okay, on this next one, I've not been saying this, and I should have been. You want it one side to always be set equal to 0, so I've got to move that -48 over to the other side. So that's going to be 2x cubed minus 3x squared minus 32x plus 48 is greater than or equal to 0. So you know if you graph this, you're going to probably have a possibility of 3 x-intercepts. So there's probably going to be 3 critical numbers. So let's see. We're going to factor this by grouping. I'll group those first 2 and the last 2. I'm going to pull an x squared out, and that leaves me with a 2x minus 3. Here I'll pull -16 out of those, so I'm left with 2x minus 3. All right, between this term and this term, I have a greatest common factor of 2x minus 3. And when you pull that out, you're left with x squared minus 16. And then that difference of squares right there factors to be x plus 4 times x minus 4. So I do have 3 critical numbers. I have critical numbers at x equals 3/2 from this one, x equals -4 from this one, and x equals 4 from this one. All right, I'm going to draw my number line. So -4, 3/2, and 4. Those are my critical numbers. So I've got 4 intervals I need to check with test numbers, or test points. So from this first interval here, I'm going to choose -5. From the second interval there, I'm going to choose 0. From this interval, I'm going to choose 2. And from the last interval, I'm going to choose 5. Again, you can choose any number in those intervals. It's up to you. It'll work the same way in each interval. Okay, so when you plug in numbers, when I plug in -5 to that first factor, it'll give me a negative value. When I plug it into the next one, I'm going to get another negative value. And when I plug it into that last one, I'll get another negative value. When you multiply a negative times a negative, that's a positive. And then a positive times a negative is a negative. So it's a negative value. Plugging in 0, I get a negative times a positive times a negative. And that will end up being positive when you multiply those out. When I plug in 2, I'll get a positive times a positive times a negative, which will end up being negative. And when I plug in 5, I'll get a positive times a positive times a positive, which will be positive. So in this interval, it's negative, and then positive, negative, and positive. And we're looking for where this is greater than or equal to 0. So we're looking at, let me put a different color. We're looking at this interval and this interval right here. Now this time it's a little different because we have the greater than or equal to symbol. So this time we're going to use brackets at those places. So we've got -4 to 3/2, both of those with brackets because of the equal to symbol. And then union because we have a break, and then we go from 4 to infinity. And infinity will get a parentheses. And that's your answer. All right, let's go to the next page. Okay, now we're going to talk about some unusual solution sets, and we've got 4 examples of those. We've got the solution set where you end up with all real numbers, or we would probably say it as negative infinity to infinity. You've got the solution set where you end up with just a single real number, and that number will be one of the critical numbers or the only critical number. And then you've got the solution set where you have no solution, and then you've got it where it's all real numbers with the exception of just one. And so you would write it something like this, where you're going negative infinity to 3, and then you have a break there with those parentheses, and then that same number to infinity. All right, let's look at some of those examples. Okay, this first example, if you tried to factor this, you wouldn't be able to. It doesn't factor. And if you actually look at the graph, it's going to be a parabola that's going to end up being up here somewhere like this. And so whenever you're trying to figure out where this is greater than 0, well, the whole thing, this entire parabola is above this x-axis. So the whole thing is greater than 0. That means that all real numbers would be your solution set, or you could say negative infinity to infinity. Oops, with parentheses. I added that, sorry. Okay, so this would be our answer. So that's an all real number situation. All right, on number 4, if we were to factor this, it would factor to be x plus 1 times x plus 1. That's less than or equal to 0. You could also say it's x plus 1. The quantity squared is less than or equal to 0. So if I were to factor this, you've only got one x-intercept. It's right here at -1. And, you know, because this has an exponent of 2, it's going to bounce at that location. I didn't draw that very well, sorry. Okay, so you're looking for where it's less than or equal to 0. Well, it's never less than 0, because if you'll notice, the whole thing is above the x-axis. There's only one spot right here where it's actually equal to 0. So we would say our solution is x equals -1. You've only got one answer for that one. Okay, let's do some more. Okay, on this one, again, that does not factor. So if you were to graph it, it would look something like this again. We're looking for where it's less than 0. Well, it's never less than 0. Less than 0 is down here somewhere, and it's never down there. So this would be no solution. You could write it out like this. The math symbol we usually use for that would look something like that. So it's no solution there. It's never less than 0. On number 6, if we were to factor this, it would factor to be x minus 2 times x minus 2 is greater than 0. Or you could say x minus 2, the quantity squared, is greater than 0. If you were to graph that, at +2, you have an x-intercept, just 1, and then it bounces there at that location. And you're looking for where it's greater than 0, not greater than or equal to 0, just greater than. Well, at the x-intercept right there, it's equal to 0, so you need to exclude that value. So to do that, you're going to say negative infinity to 2 with parentheses, and then union, that same number 2 to infinity. So what that's doing is it's doing all real numbers except for x cannot equal 2. Both of those mean the same thing. All right, let's go on to some rational functions. Okay, so for rational inequalities, critical numbers are also used to find the solution sets for rational inequalities. You're going to use their zeros and their undefined values. Their undefined values will actually be their vertical asymptotes. Those are the places that those functions change signs from positive to negative. Okay, so when you've got an inequality that looks something like this, again, you want it one side to be equal to 0. What would give you a 0 would be that top part, and then the bottom part is going to give you your vertical asymptote. So you want to get your critical numbers, you're going to see what makes that top equal to 0, which in this case is a -3, and what makes the bottom equal to 0, which would be x equals 2. And then you're going to do the same number line that we have been doing. This was my x-intercept, and this was my vertical asymptote. Okay, so doing the number line, at -3 we have a critical number, and at 2 we have a critical number. So we're going to, again, choose our test points from our intervals. So from that interval, I'm going to choose the test point -4. From this interval, I'm going to choose 0. And then from this interval, I'm going to choose 3. And I'm going to determine if it's positive or negative. So when I do -4 plus 3 over -4 minus 2, again, I don't really care what the number is, I just care what the sign is. That's going to be negative over a negative. Negative divided by negative is a positive value. When I plug in 0, I'm going to get a positive number over a negative number, which would be negative when you simplify it. When I plug in 3, I'm going to get a positive over a positive, which will be positive. So this interval is positive, this one's negative, and this one's positive. And we're looking for where it's greater than 0. So it's greater than 0 here and here. So our answer, or our solution for this, would be -infinity to -3. We're going to use parentheses because it's just the greater than symbol. And then union, because we have a break, 2 to infinity. And that's your solution. Okay, let's do another one. Okay, before we can start this next one, it has to be set with 0 on one side. So I need to move the 3 over here. So I'm going to say 2x minus 7 over x minus 5 minus that 3 when we move it over is less than or equal to 0. Now we need to get a common denominator. So I'm going to do 2x minus 7 over x minus 5. I need my common denominator to be x minus 5, so I'm going to have to multiply the top and bottom by that x minus 5 to keep it the same number that it started as. Alright, simplifying that, I have 2x minus 7. Now remember, when you do this, this -3 is what's going to get distributed through that parentheses. So that gives me a -3x and then positive 15 over x minus 5 is less than or equal to 0. Simplifying the top, I get -x plus 8 over x minus 5 is less than or equal to 0. Okay, so critical numbers. My x-intercept for this problem will come from whatever makes that -x plus 8 equal to 0, which would be x equals 8. And then my vertical asymptote, where it can also change signs from positive to negative, comes from the not x plus 5. X minus 5. What makes it equal to 0 would be x equals 5. So doing my number line, I have a critical number at 5 and a critical number at 8. It helps, I think, to draw a like a dashed line wherever the vertical asymptote representation was, which was at x equals 5, so that you know it can never equal that value. Your denominator can never be equal to 0, so you can never use a bracket for those numbers, those critical numbers. So if you draw that dashed line right there, it just reminds you of that. We're worried about it this time because we're using the less than or equal to symbol. So this time it can equal those values and brackets may be used. Okay, so we're going to focus on numbers in this interval. For my test points, I'll choose 4 for that interval. And then we have numbers from this interval. I'll choose 6. And then numbers from this interval, I'll choose 9. And again, we want to know if it's positive or negative there. So I'm going to plug it back into that fraction there. So when I plug in 4, I'm doing -4 plus 8 over 4 minus 5. So that's a positive value over a negative value, which will be negative. And then we'll plug in 6. So we'll do -6 plus 8 over 6 minus 5. And that's a positive over a positive. So that's going to be positive. And then when we plug in 9, we're going to get a negative number over a positive, which will end up being negative. So it's negative here, positive here, and negative here. And we're looking for where it's less than or equal to 0. So it's going to be on this interval and this interval. So we're going to say from negative infinity to 5. We're going to use parentheses because, again, this was representing an asymptote here. And then we'll do union. This represents an x-intercept, and so it can equal 0 at that point. And we're going to use a bracket, and we'll say 8 to infinity with a parenthesis. So this is our solution for that problem. Okay, we've got 0 on one side, which is good, but I need a common denominator, so I'm going to do 1 over x minus, I need this to have an x on the bottom, so we'll put an x on top as well to keep it the same value. All right, simplifying that, I'll have 1 minus 4x over x is less than 0. So my critical numbers come from the x-intercept, which comes from what makes 1 minus 4x equal to 0. And that would be when x equals 1 over 4, or 1/4. The vertical asymptote comes from what makes that denominator 0, which is x equals 0. So when you do your number line, your critical points are at 0 and 1/4. So when we do our test points, for this interval, I'm going to choose -1. For this interval, I'm going to choose 1/8. And then for this interval, I'm going to choose +1. All right, and then I'm going to plug it into this one to see if it's positive or negative. When you plug in a -1, you get a positive over a negative, which ends up being negative in that interval. When I plug in 1/8, I'm going to get a positive over a positive, which is positive. And when I plug in 1, I get a negative over a positive, which is a negative. So it's positive here and negative here. And we're looking for where it's less than 0, which is this interval and this interval. So our answer will be negative infinity to 0. We're going to use parentheses because we're just using the less than symbol. And then union 1/4 to infinity with parentheses. And that's your answer. Okay, I'm going to erase that just for space. All right, on this one, again, you have it with 0 on one side, so that's perfect. We just need to get a common denominator. So x plus 12 over x plus 2 minus 3. I need that to have a denominator of x plus 2, so I'll multiply it on top and bottom. All right, simplifying that, I'll have x plus 12 minus 3x minus 6. Make sure you distribute that negative all the way through. And then simplify the top. I get negative 2x plus 6 over x plus 2 is greater than or equal to 0. All right, your critical numbers come from your x-intercept, which would be what makes negative 2x plus 6 equal to 0, which is x equals 3. Your vertical asymptote comes from the bottom, which is x equals negative 2. So we're going to draw our number line. I have critical points at negative 2 and 3. Again, this was my vertical asymptote, so it cannot equal there because that would make my denominator right here 0, and that's not okay. So I need to remember that it can't have a bracket for that one. Okay, so when I choose my test points for the first interval, right there, I'm going to choose negative 3. For the interval in the middle, I'm going to choose 0. And for the interval over here on the right-hand side, I'm going to choose 4. And when I plug in negative 3, again, I'm going to plug it into this. I plug in negative 3, I get a positive on top and a negative on the bottom, so that's negative for that interval. And when I plug in 0, I get positive over positive, so it's positive on that interval. And then when I plug in 4, I get negative over positive, which is negative. And we're looking for where it is greater than or equal to 0, which is right here. So we're going to say -2 with parentheses, because this is where the vertical asymptote was, and this is where the x-intercept was. So it gets a parentheses where the vertical asymptote is. And then 3 will get a bracket. And that's our answer. Okay, on this one, you have to have 0 on one side, so I need to move that other fraction on the right over. So 1 over x minus 1 over x plus 3 is greater than or equal to 0. I need a common denominator. So I'm going to multiply this fraction by x plus 3 over x plus 3, and I'm going to multiply this one by x over x. So when you do that, you end up with x plus 3 minus x all over x times x plus 3, and that's greater than or equal to 0. All right, simplifying the top, you get 3 over x times x plus 3. When you look for your critical numbers, your top 3 will never equal 0, so you don't have an x-intercept at this time. What your vertical asymptotes will be, you'll have what makes your x 0, which is just 0. That's one vertical asymptote. The other vertical asymptote will be x equals -3, because that's what makes x plus 3 equal to 0. So that's a second critical number. All right, so the only critical numbers you have here are -3 and 0, and those are asymptotes. So you definitely can't have brackets, you can only have parentheses. We're going to do this interval right here when we do our test points. I'll choose -4. For this interval, I'll choose, I guess, -1. And when I do this interval, I'm going to choose +1. All right, I'm going to plug it back into this one. And so we're going to end up with a positive over a negative times a negative, which ends up being a positive over positive. So that's positive on this interval. When I plug in -1, I get a positive number over negative times a positive, which is going to be a positive over negative. So negative for this interval. And then when I plug in 1, I get positive over positive times a positive, which is all positive. And we are looking for where it's greater than or equal to 0, so we're looking for this interval and this interval. So my answer will be -infinity to -3. That's a vertical asymptote right there at -3, so parentheses. And then union, parentheses, another vertical asymptote, so 0 to infinity. And another set of parentheses, and that's your answer. All right, I'm going to erase one more time so we have room for this last one. Okay, again, I have to move this over so that it's set with 0 on one side. And then I need a common denominator. So we're going to do x plus 2 on top and bottom, and x minus 6 on top and bottom over here. And then simplifying that, I have 5 times x plus 2 minus 3 times x minus 6, and all of that's over your common denominator. Okay, so that gives me 5x plus 10 minus 3x plus 18 all over x plus 2 times x minus 6. Simplifying further, I get 2x plus 28 all over x plus 2 times x minus 6. All right, critical numbers come from your x-intercept, which would be from the top, so 2x plus 28. What makes that equal to 0? And I get x equals -14. And then my vertical asymptotes come from what makes x plus 2 equal to 0, which is x equals -2, and what makes x minus 6 equal to 0, which is x equals 6. So I have critical numbers at -14, -2, and 6. Okay, we just have the greater than symbol here. We don't have to worry about brackets at all, so I'm not even gonna worry about marking the vertical asymptotes this time. When I choose my test points, for these numbers, I'm gonna choose -15, When I choose these numbers, I'm going to choose, oh, and -3, I guess. When I choose the next set, I'll choose 0. And when I choose that last set right here, I'm going to choose 7. All right, when you plug those numbers in, numbers in the -15 interval will be negative, and then it'll be positive, negative, and positive. So here's negative, positive, negative, positive. And then I'm looking for where it's greater than 0, so you're looking for the positives. So that'll be from -14 to -2 with parentheses, and then union 6 to infinity. And that's your answer. All right, thanks, y'all.